goal of our Rube Goldberg machine is to turn the lights off, and we started by gathering materials that we already have, such as marbles, dominoes, balls, books, dryer, and many more that you will see later on. Day 1 was all about setting up our initial design. Well, we had to make a lot of changes because we changed our location. During our testing phases, we encountered many errors in almost every step. One of our very first change was when we decided to add a 4-pound dumbbell because a ball alone did not have enough force and would bounce away, while the dumbbell has the impact to turn the dryer on. Second was when we changed the string domino with a foam ball and has a string attached to it. This was because the domino had a larger mass than the ball, while the ball was lighter and also round, which made it easier for the dryer to blow it forward.
Our third change was made to the domino on top of the table that was attached to the string. We added a spiral of dominoes around it, increasing the likelihood of contact with the other dominoes. This ensured that when it was pulled off the table, that it would strike at least one of the other surrounding dominoes in the spiral, transferring the force, triggering the full chain reaction. Our fourth major change involved how we turned off the light switch. Originally, we had planned to use a pendulum to hit the switch off, but due to the change in location, the switch was a different type, so this was no longer possible. We adapted the design so that a heavy book attached to the switch would fall and turn the switch off. However, because the book had a large mass, it required more force to fall. So, to solve this, we added a smaller notebook above it so that when it fell, it would transfer an additional force to the book. This led to our fifth and final major change. The notebook did not fall consistently, so we attached a ruler to it, so when our pulley system lifted, the ruler would be released and fall, pulling the notebook down with it. The notebook would then hit into the book and putting the additional force on the book to make the book fall, and then it would pull off the light switch.
Step 1. The key will drop onto the seesaw contraption, which will pull the string as it lifts up. The key's gravitational potential energy changes into kinetic energy, which moves the lever and pulls the string. Step 2. The string attached to the domino will be pulled, making the domino that's on top of the other fall over, creating a chain reaction. The falling dominoes transfer kinetic energy from one to the other. Step 3. The chain reaction hits the ball that falls off the table. The ball's gravitational potential energy changes into kinetic energy as it falls. Step 4. The ball bounces onto the board, making the board turn into a ramp for the dumbbell. As the dumbbell rolls down the ramp, its gravitational potential energy turns into kinetic energy as it hits the button on the blow dryer.
Step 5. The dryer's button has a compressed elastic and Lego block. There is elastic potential energy in the elastic, as it will compress more because of the dumbbell's stored kinetic energy. Step 6. The hairdryer turns on, therefore the string-attached ball will move. This converts electric energy to kinetic energy by producing air until the ball can move. The domino that is linked with the string will knock over a set of dominoes. Step 7. 15 dominoes in sequence will transfer kinetic energy from one to the next through collision.
For step number 8, a domino hits a box containing 5 marbles as it transfers kinetic energy to it. The marbles add mass to the box to increase its gravitational potential energy. The box falls down and applies force to a lever system. For step number 9, as the lever goes up, the Lego that is within the rubber band flies to shoot the metal container. The rubber band converts elastic potential energy into kinetic energy to launch the Lego. For step number 10, the metal container will then knock a book over. The book falls down and the call bell rings, but another book will also be knocked over. When the book falls, its gravitational potential energy converts into kinetic energy and activates the call bell to produce sound energy. For our step number 11, the book pushes a ball forward. The ball has a gravitational potential energy and will go down the ramp to hit the box as it converts into having kinetic energy. Step number 12, the box with added mass on top is knocked over, causing it to fall to push the eyeglass case. As it falls, the box's gravitational potential energy is converted into kinetic energy, and the giraffe applies force to the case. Step number 13. The eyeglass case is attached to the cup by a stretchless string. After the giraffe pushes the case, its kinetic energy is transferred through the tension in the string and the cup will rise. As the cup is lifted, the kinetic energy is converted into gravitational potential energy. Step number 14. Below the cup is a ruler attached to the notebook, lying on a 2-7-foot board. When the cup has reached its maximum height, the ruler falls down and brings the notebook along with it. The notebook has to collide with the book positioned beneath the ruler, so the gravitational potential energy of the ruler and notebook converts into kinetic energy. The book has a huge mass and is attached to the light switch. It must fall down to pull the string. There is also an elastic ready to pull the switch down to turn off the lights. The elastic stores elastic potential energy, which then releases and pulls the switch downward. That energy interrupts the electrical energy flowing to the light, which means the flow of heat and light stops.